Hi everybody, so this is going to be the second one into lab math calculations. Again, it just as a help for our basic lab math calculations. So what is the molarity of a solution containing 50 grams of sodium chloride per liter? So the formula that you want is mass equals concentration times volume times molecular weight. Sometimes the question will give you the molecular weight or they'll not give you the molecular weight of the molecule or of each atom, depending. And so if you look in the table of the elements, it's the bigger number. So this is the atomic number, this is the atomic weight. And so the molecular weight would be these added up. Since we have one molecule of sodium and one molecule of chloride, we would add these up. Now if you had, two of sodium to whatever, like you would have to double that. So you have to respect that. But we're just going to go here with the sodium chloride. And so that would be the first thing that we would do. Enter. So we would go 22.99 plus 35.45, and that's going to give us our molecular weight of sodium chloride. So 22.99 plus 35.45 equals 58.44. So 58.44, that's the molecular weight, okay? And so it's actually grams per mole per molecule. So, okay. So then in the problem, we're given a mass, that's to 50 grams. So mass is weight, so 50 grams equals the concentration is what we're asking, that's the molarity. So we're just going to put BC, a big C there for concentration, times our volume. Is per liter, so our volume is going to be 1 liter. And then times the molecular weight, so it's 58.44. Okay, so just go molecule here. So then we need to solve for C. So then you would have, basically, I'm just going to leave the units out here, equals C times 1 times 58 is going to be 58.44. And so then C is going to be equal to, we just divide both sides of the equation by 58.44. So that would be 50 divided by 58.44. And so we're going to do that here. 50 divided by 58.44 equals, and then let me scroll up so you can see 0.8555. So 0.8555. So we could round that. A lot of times it's going to be rounded, and so it's a 0.9 molar. That's the molarity of this solution. So we can do this again. This one is slightly more complex because it's one is giving you the molecular weight already, so you don't have to calculate it, but it's giving you 25 grams of sodium hydroxide with a molecular weight of 40 is added to 0.5 liter of water. But then they throw a trick to say what's the molarity of the solution if you add an additional 0.25 liters of water. So the first thing is that you are going to get your total volume, and so it's 0.5 plus 0.25, so it's going to be 0.75 liters, okay? And then we're going to do the same formula as we did here. Mass concentration times volume times molecular weight. So the mass was 25 equals, the concentration is what we're looking for, times the volume is 0.75 times the molecular weight, which is given for you, which is here 40, okay? And so we can say now that's 25 equals, so we're going to go here, 40 times 0.75, so go ahead and do that. So that's 30. So it's going to be basically 30C, or 30 times C, if you will. Okay. So then, again, we're going to isolate C, so we're going to do divide both sides of the equation by 30. So that would be 25 divided by 30 equals C, which is, if you solve that, then you're going to go 25 divided by 30, and it's 0.8333. 0.3. So if you rounded molar, so if you rounded, that could be 0.8 molar, and that's your concentration. So your molarity. So then next we have problems asking what is the percent concentration by weight volume of an aqueous solution of 30 grams of sodium chloride in 1 deciliter of solution. Okay, so for that, the percent concentration a lot of times are done in 100 mils, and so you just have to know that 1 deciliter is indeed 100 mils, so we can use that. We can just convert that. And so the way this works is your percent concentration is going to be your 30, and I'm going to try to get out of bold here in just a second. Well, never mind. I guess I'm staying in bold. I'm not going to, well, I could do this. I was just trying to keep this up and hidden away, but it'll be all right. So for all of these, we're going to use a lot of C1, V1, C2, V2. Okay, so the percent concentration, weight over volume of an aqueous solution of 30 grams of sodium chloride in 1 deciliter of solution is just going to be the 30 grams over the 100 mil. And so basically, you're going to do 30 divided by 100. And so that you should know that I'm going to show you in a calculator, but you should know what it is. But 30 divided by 100, there you go. So it should be 0.3. So you convert that to percentage, so that becomes 30%. And so the percent concentration by weight volume of this aqueous solution of 30 grams of sodium chloride in 1 deciliter or 100 ml of solution is 30%. So what is the percent concentration of 12 grams of potassium hydroxide in 100 grams of solution? So this is weight. So it's all, instead of being in 100 mils, it's going to be in 100 grams. And so it's basically 12 grams in 100 grams. So you're going to do 12 divided by 100. And so you should know that one too, but we'll just do it on the calculator, divided by 100, so that gives you 0.12. And so you convert that again to percentages, and so 0.12 is 12%, so the solution to that one is 12%. Okay, now here's where we're going to use this formula. Probably shouldn't have put it there, I probably should have just actually moved it down here. So we're going to do a little more fun, practical one. So what's the percent alcohol concentration? In volume per volume, if you mix 20 mils of tequila, which is alcohol, right, with 80 mils of margarita mix. Okay, so this one's pretty easy. We're going to put 20 of tequila plus 80 of the mix. So you would have 100 mil total. So then your percent alcohol concentration is 20 mils of alcohol in 100 mils total. And so this is the trick, is you have to get to the 100 mils total. And so 20 divided by 100 is going to be 0.20, which is 20%. So it's a 20% alcohol solution. So, sorry, don't need this one yet. We actually need that down here. Okay, now we're going to go from one percentage to another percentage concentration. So now this is when you really want to start messing with C1, V1, C2, V2. So how would you prepare 520 mils of a 5% weight volume solution of sodium hydroxide from a 20% weight volume solution of sodium hydroxide? So you're starting with a 20%, you're going to end up with a 5%. And you need 520 mils of it. And so you're going to dilute it. You're going to dilute a more concentrated solution. And so usually C1V1 is your stock solution and C2V2 is your final solution. So our stock solution, the concentration is 20%. So we're just going to put 20. We do not know what V1 is. That's what we're looking for. We're looking for that volume. And we know what we want to end up with. We want to end up with 5%, so 5. And we want to end up with 520 mils. Okay. So then we solve for V. So we have 20 times V equals, and then we're going to go here, 5 times 520. So it's 2,600. Okay, and then we, isolate V, so we're going to divide both sides of the equation by 20. So we can get rid of that 20 here. So V is going to be 2,600 here divided by 20. So it's going to be 130. So that is how much stock solution. So this would be 130 mils of the 20% stock solution. But it's asking you how would you prepare it. So first you got to start with 120 mils of that stock solution, and you're going to dilute it. So then you're going to add a diluent like maybe water to it. And so the way you figure out how much of the diluent you need, so you know that your total volume at the end is going to be 520 mils. And from that, you know that you need, you will, of that total, 130 mils is going to be your stock solution, so minus 130 mils. And so now we just do the math really quick. I'm just plugging it in here so I don't make any mistakes here. Divided by minus 130, so 520 to minus 130 is 390. Okay, so then practically how do you make it? So you're going to mix 130 mil of the 20% stock solution with 390 mil of your diluent, water or whatever it is, and that is the answer. That's how you would prepare, and you would end up with 520 mils, because if you add 390 plus 130, you get 520. So then how would you make 250 mils of a 2.0 molar solution from a 12 molar solution? Well, don't let that freak you out. It's the same formula, C1V1 C2V2. Instead of being percent, we're just going to use molar. So one of the things to remember is, if C1 is in percent, then C2 is in percent. If C1 is in molar, then C2 is in molar. If V1 is in milliliter, then V2 is in milliliters. Things have to be equal on both sides of the equal sign in the equation. So, okay. So, our C1 is the stock. We're going to do stock. So we're starting from a 12 molar. So it's going to be 12 molar. It's going to be 12. And then we need to know what V1 is going to be. And then our C2, what we want to end up with is a 2 molar. And we know that our V2, we need 250 mils. Okay. And so again, we're going to solve for V. Let me actually move this down to this page here and scroll. Okay. So we're going to solve for V1. So we're going to go, right now it says 12V equals 2 times 250, so that should be 500, right? And so then you can go V per mil, but then we're going to go, C per mil. We're going to go V, divide both sides by 12. I'm just really dealing with the numbers right now. And it's going to be 500 divided by 12. So then we get our calculator, we go 500 divided by 12. And that's 41.666, so 41.6666. Well, practically, let's just say 42 mils, because that's just easier to measure. And so then how do you prepare? Then you're going to take 42 mils of your 12 molar solution, and you're going to mix it with, and then we need 250 at the end, so it'll be 250 minus 42, which is equal to, 208, really. I don't even need to use that. 208 milliliters of diluent. Sorry, I'm not putting my units everywhere, but so yes, 250 mil, 42 mil. So practically, you're mixing 42 mils of your 12 molar with 208 mils of your diluent, and then you'll end up with 250 mils of 2 molar hydrochloric acid there solution. So then same thing here, C1V1, C2V2. How do you prepare 400 mils of a 10% weight volume solution sodium hydroxide from a 40% weight volume solution? So our stock concentration is 40 times the volume equals, what do we want to end up with? 10% times 400, that's V2, and so 40V equals 4,000. 4,000 V is going to be 4,000 divided by 40, and so that should be pretty easy. You can simplify, so that would be 100, and so how do you do that? So then you would mix 100 mils of your 40% solution, stock solution, with, and then you want 400 mils is 400 minus 100, so that would be 300 milliliters of your diluent water or whatever. So that's how you do that one. So same thing, we're just going to continue. So it's just basically, they always give you 3 of the numbers, and you just solve for the one that you're missing. So how would you prepare 750 mils of a 50% volume by volume ethyl alcohol solution from a 95% volume by volume solution? And so again, C1, we're starting with 95%. We need to find V1. C2, we're going to end up with 50%, and V2, we want 750 mils. Okay, same thing. So we got 95V equals, and then we can do here 50 times 750 is 37,500, and then V is going to be that divided by 95, so we're going to be 37,500 divided by 95, so 394.7, 394.7, so you could say 395 mils, so you would mix 395 mils of your 95% alcohol solution with, and then so you wanted 750 mils total minus the 395 that you're mixing, and so you just quickly go here, 750 minus 395 is 355, and so 355 milliliter of diluent. There we go. So that's what you would mix. You would mix 395 of that stock solution with 355 mils of diluent. And so basically I'll do one more, but it keeps doing the same. Now, sometimes if it says, for example, how do you prepare a 10% bleach solution, 250 mils of a bleach solution, what you have to assume is that your stock concentration, if they just say bleach is 100% bleach, so then your C1 is going to be 100%. And so if you want to, we can just do that. How would you prepare? Let's just go a 10% bleach solution, and you want, let's go a random 350 milliliters. If you need 350 milliliters, let's go over here. Okay, so this could throw you off for a second because you're like, okay, what is C1? What's your stock concentration. Well, it's 100% bleach. It's nothing but bleach. So that would be 100% bleach times the volume is how much of 100% bleach do you need? Sorry, big B. That's what we're going to find out. And you want the concentration to be 10%, and you need 350 mils of it. And so that's how you set it up. So then 100 V equals 1,100, and so V is going to be equal to 500 divided by 100, and so it should be 35 mils. And so you would mix 35 milliliters of bleach with, and then you would do 350 minus 35, and that would give you 315 mils of water. So you would measure out 350 mils of water, add 35 mils of bleach, and you have 350 mils of 10% bleach solution. So, all right, so that's going to wrap up our recording here for that, and I hope